Polynomial word problems, as with any word problems, means we're going to have to try to set up a polynomial equation. If you're lucky, it may be given to you. Let's take a look at this one. Geometry is a common place to find polynomial word problems because now we can actually use volume where we're going to be possibly multiplying dimensions 3 times, giving us a cubic equation to solve. Okay. So the height of a box is 2 centimeters less than the width, and the length is 4 centimeters more than the width. If the volume of the box is 8 times the measure of the length, what are its dimensions? Okay, so let's start by breaking it down. So let's label, we have a box, we have a rectangular box. We don't know if any of the sides are the same. We have a width, a length, and a height. We know our volume is equal to length times width times height. And generally we just kind of want to lay out what we're doing here before we get started. So now let's try to see if we can define just a single variable, because now we have 3 variables. We'd like to get it down to 1 or possibly 2 if we can. So let's write everything in terms of the length and the height are both identified in terms of the width. So let's let the width of the box equal W. And it's important to define what your variable means in a case where you're going to be defining other variables in terms of a single variable. So now we have that the height is 2 centimeters less than the width. So that's W minus 2. And then our length of the box is 4 centimeters more than the width. So that would be W plus 4. So now we know the volume of the box is 8 times the measure of the length. So let's see if we can substitute our values for our variables into, so we got V equals 8 times W plus 4. I'm writing that instead of the length. We've redefined the length in terms of the width here. So now I'm going to replace everything in my volume equation with what I've come up with in terms of W. So I have 8 times W plus 4 equals W plus 4 times W minus 2. Okay, so now I'm just going to expand everything out. I get 8W plus 32 equals, well, I get W squared plus 4W times W minus 2. You can show as much or as little work as you like here. 8W plus 32 equals W cubed plus 4W squared minus 2W squared minus 8. So now we're going to try to get everything on the same side. We're going to subtract from both sides. So we have total of 0. I'm going to go up here. 0 equals W cubed. I'm going to move everything to the right hand side. W squared, I have a total of 2. So plus 2W squared minus 8W minus 40, okay, because I'm subtracting 32 from both sides. Okay, and notice, sorry, this should be minus 8W. So sorry, this should be minus 16W minus 32. It wouldn't be a good video without a nice mistake in there, right? Because we don't actually have any numbers that are being multiplied here. They all should be multiplied by a W. Other than that, it actually is okay, now that I'm taking another look back. Okay, working down. So now we have our rational root theorem. Says we have our, it's going to be this A naught factors over a sub n factors. So we're looking at plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16, and plus or minus 32. Okay, so I'm really keen to try to do it with a smaller number rather than a bigger number. So I am going to try, I'm going to look at 1. I can see 1 cubed is not going to work. I'm going to try negative 1. So I have negative 1 plus 2 plus 16 minus 32. That's not going to work. So now I'm going to actually plug in, let's try positive 2. So we have 2 cubed plus 2 times 2 squared minus 16 times 2 minus 32. Okay, so that's with a positive 2. I can see we have 8 plus another 8. That's not going to work because I'm going to be subtracting 16 minus 32 twice is going to be negative. So that one doesn't work. So let's try negative 2. So negative 2 cubed plus 2 times negative 2 squared minus 16 times negative 2 minus 32. Okay, so this gives me a negative 8. This gives me a positive 8. This gives me plus 32, and that gives me minus 32. So that is definitely promising. So it looks like if I plug in negative 2, that's going to be a factor of this equation. So what I'm going to do is I am going to, that is a root of this equation. So I know that 0 equals something times x plus 2. So what I want to do now is I'm going to use a little bit of synthetic division. So we'll go over here, and I've got minus 2, and we're going to divide it into 1, 2, negative 16, minus 32. So I bring my 1 down, I get 1. 1 times negative 2 is negative 2. I get 0. I get negative 16, and negative 2 times 16 is positive 32, verifying I have no remainder. So here I get x squared minus 16 is going to be what I have left over. I'm going to rewrite this now, going back over here as 0 equals x plus 2 times x squared minus 16, and that's going to be equal to x plus 2, x plus 4, x minus 4. So now I get my answers are negative 2, negative 4, and positive 4. Of these, only positive 4 is going to work. We reject because lengths must be positive. So now we're going to go back and see if we actually get reasonable answers that fit our description. So our width is going to be 4, our height is going to be 2, and our length is going to be 4 plus 4, which is 8. And if it says our volume should be 8 times the length, and so our volume, just to check, is 8 times 4 plus 4, which is going to equal 64, which is in fact 8 times the length. So these are the dimensions, and so this here is our final answer with what the dimensions are. Okay, so we're actually putting together all of the methods that we've already learned for how to solve these problems. Let's take a look at another problem. 3 consecutive integers have a product of 105. What are they? So how do we write consecutive odd integers? So they're integers in a row, so they have a product of negative 105. Okay, so if I let the first integer equal, well, it has to be an odd number. How do I make sure it's going to be an odd number? Well, I know that 2x is an even number, so that means 2x plus 1 equals an odd number. 2x plus 3 would be the next odd number, and 2x plus 5 would be the next odd number. However, this would give me reasonably big numbers, so rather than 2x plus 5 going up again, I'm going to actually go down 2 from 2x plus 1, and I'm going to write 2x minus 1. So my consecutive integers and if I want to write them in order, I'd really want to write 2x minus 1, 2x plus 1, and 2x plus 3. Okay? They have a product of negative 105. So I'm going to write that's the answer to multiplication. So I've got 2x minus 1 times 2x plus 1 times 2x plus 3 equals negative 105. And I'm going to have to expand all this out. Sorry, kiddos. So 2x minus 1 times 2x plus 1, thankfully, is 4x squared minus 1. Thank you. Difference of 2 squares times 2x plus 3. That's equal negative 105. I'm going to expand again, so I get 8x squared minus 2x plus 12x squared minus 1 minus 3, equals negative 105. Now I'm going to add to both sides, add 105 to both sides, so I get this, sorry, should be 8x cubed. So I get 8x cubed plus 12x squared minus 2x plus, if I add 105 here, I'm going to get 102 equals 0. I can divide everything by 2, so that gives me 4x cubed plus 3, sorry, 12 divided by 2 is 6x squared minus x plus 51 equals 0. Okay, so I'm looking for roots. I'm looking for numbers that divide evenly into 51. I feel like something went a little funky sideways here. That's okay. So what numbers actually go into 51? Well, I know 3 goes into 51. So 51 is 3 times 13. So those are the factors I'm looking at. So remember, I'm not actually, and it could be over 4, I'm not actually looking for what x is. I'm looking for what my integers are. So let's go back. I'm just going to really quickly make sure I didn't make any silly mistakes here. So 2x minus 1, 2x plus 1, and 2x plus 3. That should be okay. That's all fine. That's all good. Okay, nothing I did that was too silly so far, I think. I may come up with something at some point. Okay, so now what we're going to do is we are going to try to find, so we can have plus or minus 3, something over 4. I'm just going to try 3. Okay, I'm actually going to try, let's try a negative 3. So I have 4 times negative 3 cubed plus 6 times negative 3 squared minus negative 3 plus 51 equals 0. So let's see, that is negative 3 cubed is negative 27, so 4 times negative 27 is negative 108. Plus 6 times 9 is 54, plus 3 plus 51 equals 0, and that does in fact work out, okay? So that is going to equal 0. So now that we've got that that's equal 0, we know that a root of this equation is minus 3, okay? So we have x, so x plus 3 is a factor. Okay, so what we're going to do is we are going to do our polynomial long division or our synthetic division. I prefer synthetic. So we've got 4, 6, minus 1, 51. We're going to bring down our 4. We get 4 times minus 3 is negative 12, plus 6 is negative 6, times 3 is 18. 18 minus 1 is 17, and 17 times minus 3 gives me negative 51 and 0, which shows me the only mistake I made is that 51 is actually 3 times 17 and not 3 times 13. Okay, so moving down, what we're going to do is we know that this is 0 equals x plus 3 times 4x squared minus 6x plus 17. So I want to see if this is going to have, all I'm going to do here to check this is I'm going to check b squared minus 4ac. In order for this to give me another integer, then this would have to be greater, this would have to be a perfect square. So b squared minus 4ac is negative 6 squared minus 4 times 17. And from what I can see is that this would give me actually no real solutions for x, or no real zeros for x. And the reason is that if we were to do the quadratic formula to solve this equation, we would actually get here a negative under the square root, so that would mean there were no actual solutions. So the only solution we get is x equals minus 3. Okay, so we'll go back up here. All this polynomial math showed us that x is equal to negative 3. Now we can plug back in and figure out what our numbers are. So 2 times negative 3 minus 1 is negative 6 minus 1 is negative 7. 2 times negative 3 plus 1 is negative 5. And 2 times negative 3 plus 3 is in fact negative 3. So these are my 3 numbers. And so on your test, generally you're going to be asked to use polynomial methods to do something specific, because what somebody might point out is if 3 consecutive odd integers have a product of negative 105, they have to be negative, and one of them is probably 5 because they multiply to make 5, something with a 5. So that point aside, what we're trying to do is demonstrate how to use polynomial methods to solve these things, and that is the way your questions will generally be phrased, so there's no way around having to show out all the work.